Hi everyone, this is Prithvi Reddy Mekala. Today in this video, I am going to give a brief explanation about SAP CPI and also SOAP framework, REST framework and ODATA framework. So after integrating CPI with all other SAP cloud tenants, this CPI, as you know, generally it acts as a middleware. So there should be some connecting links after integration to transmit the data, and all those connection gaps are filled by HTTP methods, SOAP framework, REST framework and OData. So these SOAP, REST and OData and HTTP methods which are used in them helps to just transmit the data between the cloud tenants and S4HANA by just keeping CPI as a middleware. So generally CPI stands for Cloud Platform Integration. So all the cloud tenants will be integrated with CPI on a data transmissions like requests and response takes place. So now I am going to tell you about HTTP methods and what is SOAP architecture framework and what is REST framework and what is OData and finally what is CPI. Just a brief information which will let you know about all these. So generally now we'll start the session. So as you see, the first thing is HTTP or HTTPS. Generally HTTP is a protocol. HTTP stands for Hypertext Transfer Protocol. So browser is an HTTP client. So HTTP takes place through TCP and IP sockets. IP, like internet protocol. HTTP just takes place through internet protocol, and data or resources are referred by URL. In HTTP, all the data and resources are referred by URL, which you see like google.com or something. All URLs, you know about that. And HTTP is a stateless protocol. Here I want you to understand the difference between what is stateful and stateless. The difference between stateful and stateless, I want you people to know. In the stateful protocol, like in the stateful frameworks or stateful architecture or stateful protocols, what happens is when the browser sends request to the server, then the information will go from server to browser again. So in this process, if the server just records the data or remember the data or server stores the data, then it is stateful protocol. If the server doesn't store the data and the memory is lost when the transaction ends, it is stateless protocol. So here if you see, HTTP is a stateless protocol and cookies are supported. And request, in HTTP we have requests and headers. While you are just writing the code, you will be having headers and also body. And HTTPS. HTTP, as I already told, Hypertext Transfer Protocol, and HTTPS, and the S stand for secured, and you will need some credentials like password or ID password or something to access these kind of protocols, where if there is HTTPS, S stands for secured, and this is about HTTP or HTTPS. And we have methods in this to just modify. Just like we have HTTP methods like get, post, put, delete. These are HTTP methods which we'll use while requesting something. And next thing is REST framework. Generally, REST stands for Representational State Transfer, and REST is a stateless protocol. It's a stateless architecture, and the server doesn't store data. Memory is lost when the transaction ends. It's once in one time. I mean, it's independent of anything. It needs its own credentials every time we use that. And in REST architecture is made up of HTTP methods. As I told, all the HTTP methods are used in REST, and also some extra its own APIs, application program interface, its own APIs. REST have its own APIs, including HTTP methods. So HTTP methods plus its own APIs is equals to REST, representational state transfer, and there will be no async, and it is stateless and lightweight. Generally REST is used for only lightweight applications because it's for heavyweight applications we use SOAP. It's not like much supported, like when there is a large data, REST is not much helpful. We'll use SOAP instead of it, and we'll get into SOAP later. And next, it is caching supported. It forms caches. And next, XML or JSON supported. REST is XML or JSON supported formatted, and also it has its own built-in error handling. REST has its own error handling. It does not. It's actually language dependent. It doesn't depend on the language. It has its own error handling, and it calls services through URI. You know about URI is a part of URL. You will see that. And also, it is easy to call from JavaScript. It is easy to call from JavaScript, and also it supports SSL and request and response APIs. As I told, it has its own application programming interfaces, and it is a data-driven model. And you know, JAX RS, JAVAX and RESTful services for Java that we use in REST. And also, as I told, it is language independent. REST works with firewalls. It has firewalls. It has protocol and secured. And it's platform independent. REST is a platform independent. And next thing is OData. As you know, REST contains HTTP methods plus its own APIs. OData, if you come to OData stands for open data. In open data or OData, it is contained with REST architecture plus its own application programming interfaces. In OData is a combination of REST framework plus OData's own application interfaces. This is OData. OData stands for, I said, open data. Actually, OData is also a stateless protocol because it works on stateless protocol, and once the transaction is done, memory is lost. That's all. The server doesn't store the data as it is a stateless protocol, and it entirely works on a REST framework principle, and it is queryable. Like you can perform queries, and you can modify, update and create data through OData. And also it is widely used for SAP apps. It supports Atom and JSON encoding. Supports Atom, XML Atom. You know about XML. XML framework is Atom. So Atom is an XML framework. It supports Atom and JSON encoding. Entity or service data model. It is an entity or service data model. EDM stands for entity data model and creates entity objects. So it is an EDM. And also it is metadata or services. It's MDM, metadata services, metadata document or metadata services document, anything. So this is about OData. OData is extensively used in perspective of SAP because SAP is the one which created OData. And next is SOAP framework. SOAP stands for Simple Object Access Protocol. Simple Object Access Protocol. It's async support. Here REST doesn't support async, but SOAP supports async. It's heavy bandwidth and stateful. As these three, like HTTP, REST and OData, like all these three are stateless, but when it will come to SOAP isn't stateful. SOAP is stateful protocol, and the server remembers data. Example for SOAP protocol, like SOAP framework is, suppose let us take any social media website or something. You will be having some login ID and password, and once if you logged in and do some changes, it will be saved. So again, multiple times, if you keep on logging in, like today you will log in, you do some changes in your, like your post something, and again if tomorrow it will be like that only and no changes. So the server like it is storing the data. That's why SOAP is called stateful. If sometimes you made a conversation with something, and if you come and see, it won't be visible. It gets automatically deleted. For example, like we have applications like Snapchat. If you don't save the information, you have a conversation with your friend or someone, and it gets deleted finally. So that is stateless again, because like the server don't store the data. Like memory is lost when the transaction ends in all these three, but in SOAP framework the server stores the data. So SOAP is the only one which is stateful protocol here in this form. So no caching, and like web, email, private networks, it supports the SOAP, and also service invoked through RPE. SOAP service just invokes through RPE, and no error handling. It doesn't have its own error handling. Again, it depends, it's language independent. And like web services and XML, like it supports XML format. SOAP supports XML format. And this is about brief information about HTTP, REST, OData, and SOAP. Now we will see the working of like how data is requested and how data is responded again. Requests sent and response coming back. That we'll observe in both the REST framework and SOAP framework. First we'll come to RESTful web services, REST framework. In REST framework, the code that what we'll use is WADL, which and for SOAP architecture we'll use WSDL. Web application descriptive language, that's what we'll use in RESTful web services. WSDL stands for Web Services Description Language, which is used in SOAP framework. So in REST framework, what happens is, as you know, we use HTTP methods. Here the client, by using HTTP methods, first he will request. How you are going to request? Request, as I said, like get, post, put. These are the methods that we will use in request while you are calling data. So when you request, and it will come to REST APIs. Then next, after requesting, you should use some REST APIs. There what happens in REST APIs is REST request handler, REST service handler, and REST database handler. All these three handlers will come into action in REST APIs. Like by using REST APIs, you are querying like what the exact information you need, you will just get it. And again, from these REST APIs, after querying by all these handlers like REST request handler, REST service handler, and REST database handler, again the API just start responding. Again the query result will go in which format, XML or JSON format. These are the supported formats in REST framework. In XML or JSON format, the response just goes out again to client or browser. This is the REST architecture, and the process just takes place like this. Just like a client sends the request and server sends the response, and REST API handlers in between, they will request servicing and database handling. Everything is done by REST APIs. So we will use this REST actor in many things like web apps, cloud apps, server apps, data, mobile applications, legacy apps, parameter apps, everything, anything. In everything we use RESTful web services, REST framework. Next, if you come to SOAP, here we first, as SOAP stands for, as it was simple object access protocol. First there will be SOAP sender. SOAP sender will send a request. Request here, request will be in the request contains or request, it will be in the form of, first it will have HTTP header, and next is SOAP envelope. And in SOAP envelope, we will find SOAP header and SOAP body. Just like HTTP header and SOAP envelope. We have two, HTTP header and SOAP envelope. In SOAP envelope, we will contain SOAP header and SOAP body. This is what, while you are sending request from SOAP, this is what it contains. And it will go to SOAP receiver. And again from SOAP receiver, the response it will come like, and again the response contain the same thing, HTTP header, SOAP, again SOAP envelope. In SOAP envelope we will find SOAP header and SOAP body. This is what client sending request, again it is responding. In between same thing will have like both for response and request will have HTTP header and SOAP envelope. But in SOAP envelope again we have SOAP header and SOAP body. That's all. This is SOAP architecture. SOAP, as I said, it is stored stateful. REST is for lightweight applications, but SOAP is for heavyweight applications. SOAP no for like for big projects and all where there is a lot of information, then SOAP is most preferred one. And if you come to RESTful web services for lightweight applications, again OData is compatible for both, because OData it's queryable and it can sort out from a lot of data too. But SOAP is the most preferred one. Actually, generally, with CPI integrations, we use all of these depending upon the preferences of data. Like sometimes we use SOAP, sometimes we use REST, sometimes we use all combinedly, combination of all. And as I told, REST is based on WADL, Web Application Description Language, and SOAP is based on WSDL, Web Services Description Language. So now we will see some differences between WADL and WSDL. In WADL, it's a mission readable code, no authentication is required, no XML standards, URI mechanism is very important here, no binding to SMTP server. So these are the characteristics of WADL. And when you come to WSDL, it's an abstract class like types, messages, operations and port types, that and all like it's services, right? So based on this. And also it implements concrete port like interfaces, and also bindings, services, ports. Only XML parentheses. XML parenthesis is very important in WSDL as it is a SOAP protocol. And also authentication is must, where you don't need authentication in WDL. And W3C recommended, recommended by W3C, this is what SOAP architecture. That's why SOAP architecture is used in heavyweight applications. And this is about HTTP methods, REST architecture, and also SOAP framework, and again OData briefly. Now we will get into OData briefly. Now we understood REST framework and SOAP framework. Now we will get into OData, which is very important. So firstly, OData, as I told, it is an EDM. OData is an EDM. EDM stands for Entity Data Model. So OData is Entity Data Model, and entity objects are created in Entity Data Model. So first service model is, as I said, entity, an entity reference. Just you can read URLs, you can edit URLs, and it's a transient entity. OData is a transient entity where you can read URL and edit URL. And data model is based on annotations. We use annotations in OData. And we have protocol versioning and model versioning in OData. These are some types of versionings. So majorly we use protocol versioning and model versioning in OData. And the supported formats for OData are JSON and Atom. As I already told, JSON and Atom are supported formats in OData. Atom is a framework of XML, whereas JSON stands for JavaScript Object Notation, which is language independent, and it's a powerful tool where for transmission of information we use, as it is language independent, it is used in Java, Python, JavaScript, in anything. So JSON is a very important tool to be just learned. And next, if you come, we have some requesting changes, like we'll use data links. Delta links are used for requesting changes in OData. And next, if you come, data modifications. OData is mainly used for data modifications, like alerts, date, time, offset values, constraints, returning results, and all. Data modifications we do like creating an entity, updating an entity, upsetting an entity, and relationship between entities. All you do modify, create, edit, and delete, and all. And next you manage media entity like create, edit, and delete, and managing stream and everything. So as you are able to create, update, delete, and edit and upset the entities, objects here, OData is majorly used for querying. Querying is the major concept behind the OData. You can just query the data, get the specific data. This is what the main importance of OData. OData completely it is built on REST APIs, representative state transfer application programming interfaces. And next, if you see, you can just there are some requesting data like OData. Again, as I said, we use REST. Again, REST uses HTTP. So in OData, you use HTTP requesting methods and response methods like search, filter, count, order by, skip, and top. And there are some server-driven methods like expand, select, and format. These are the things used in OData. And next, if you come to data, all these are like search, filter, count, order by, skip, top, and like server-driven like expand, select, and format. All these are data service requests which you use in OData. Next, if you come to built-in operators, there are many built-in operators. There are like comparison operators like all general, and there are arithmetic operations like all general like in Java and all. And next, if you come to type functions, there is cart and is off. These are type functions that you use in OData. And there are some geo functions like geo distance, geo length, and geo interaction, which you use in navigation, typing in OData. And next, there are logical operators, same like in Java and all. And there are mathematical operations in general, and also like round, floor, and ceiling and all. And there are date operations like year, month, day, hour, minute, second, date, time, now, and minimum date time, maximum date time. So these are some date operators related to date. And next, if you come to string functions, there are on lines, end with, start with, length, index of, to lower, to upper, trim, concat. These are string functions. So these are built-in operators and some string functions that you observe in OData. And next, if you come to extensibility here, payload extensibility, query option extensibility, action extensibility, function extensibility, vocabulary extensibility, header extensibility, and format extensibility, where you use this extensibility based on your requirement in OData. And next, if you come to response status codes. So there are some response status codes which for every code there is a function. So, suppose there are some success codes like 200. If the code is 200, then the response is okay. If 201, response is created. 202, response is accepted. 204, there is no content. And 301, then it is redirection. 304, then it is error response. So these are success codes. Then if you come to error response, 404 not found, 405 method not allowed, 410 gone, 412 precondition failed. And if you come to server error response, 501 it's not implemented at all. Well, again we have some instances. As these codes, just like general description, you need not to remember these codes. It's already available. It's not an issue. And next, if you come to context URL, there are many things like when there is an URL for OData based on REST architecture, there will be many contexts and many types of entities, and also many types of responses and primitive types and all in context URLs. Like there will be different context URLs, like you will contain service documents and collection of entities, singleton entity, collection derived entity, collection of projected entity, projected expanded entity, collection of entity reference and property value, and delta response, cross and response operation result, and also complex or primitive types. These are all just involved in the context URL based on which type of data you are going to request. So this is about context of URLs, different contexts of URL. And next, if you come to header fields, first there are some common headers like content type, content encoding, content language, content length, and content version. So these are common headers. And if you come to request headers, we have header accept cassette, header accept language, header accept if match, header accept if not made, header OData isolation, header OData max version, and header prefer. These are some header fields, request header fields. And if you come to response header, we have header etag, header location, header OData entity, header preference applied, header retry after. These are response headers. And finally, there is conformance. OData service confirmation levels. We have some OData service confirmation levels like OData minimum confirmation level, intermediate confirmation level, then advanced confirmation level. These are confirmation service levels. And if you come there are also interoperable OData clients which helps in requesting the data. This is about conformance. So finally, we got to know about HTTP, REST, SOAP and OData. What you have to remember is OData works completely on REST principles. We use REST methods as well as REST APIs, and as well as it also have its own APIs. So this is about OData, REST, SOAP and HTTP methods. Now we'll get to know about SAP CPI. SAP CPI, like as I had already told, CPI stands for Cloud Platform Integration, which is an SAP Cloud tenant. Mainly, it acts as a middleware between C/4HANA and CPQ Cloud tenants, and between it will be in between, and also S/4HANA. It's just like C/4HANA cloud tenants. C/4HANA have 5 clouds like Hybris Commerce Cloud tenant, and in C/4C we have 2 cloud tenants like Sales and Services Cloud tenants, and we have SAP Customer Experience Cloud tenant, and we have Hybris Marketing Cloud tenants. Totally 5 clouds are there in C/4HANA. So these 5 cloud tenants, and another one SAP CPQ Cloud tenant. CPQ stands for Configure Price Quote Cloud tenant. So between any of these cloud tenants and S/4HANA, in between these cloud tenants and S/4HANA, which acts as a database, in middle there will be CPI, which acts as a middleware, sorting out and querying the data and implementing the data separations and all. It is done in cloud platform integration, and it integrates with all other clouds. It's one of the most powerful cloud tenant created by SAP. So now it makes the work very easy, and it makes the works very fast and more understandable and more accurate. This is what the importance of SAP CPI. So in SAP CPI dashboard, you will be having all these things like projects, data stores, tasks, scripts and functions, security, data flows, monitoring and admin. All these just we can observe in SAP CPI dashboard. So if you see, the first thing is projects. In projects, what you do, like you create sub account, you enable Cloud Foundry and subscribe process integration, assigning user roles, tenant provisioning, and create service instances. This is what you do in projects. When you come to data stores, you import object types like tables, extractor and functions. In data stores, you import object types, and there is some DS types in applications like SAP BW source, SAP S/4HANA source, SAP Analytics, OData adapters, and Oracle or SY base, and also you will be having HANA database. This is what you will observe in data stores. And if you see tasks, creating tasks, importing and exporting, versioning, rollback, replicate, execute, promote, load, define global variables, run parallel, delta load and delta flow, all these are tasks that are assigned to CPI, that are performed in CPI. And next, if you see scripts and functions, all extensible scripts are through processor editor. So generally what you want to do is, you have to enable the Cloud Foundry in the CPI, like you have to configure the availability of Cloud Foundry in CPI to just for scripting process. This is what you do in CPI. Actually in CPI you perform groovy scripting, which is language independent. It can be in plain script, or it can be written in JavaScript, or it can be in XML format. It is just language independent. What the scripting you do in CPI, it's called groovy script, that you can also check on internet. And next, if you see, there are some functions of like date and time functions, database info functions, file operation functions, date or validate functions, math functions, and data type functions. And if you come to scripts again, there will be function calls, assignment operators, arithmetic operators, loop and controls, and condition statements, and all like same like in Java, Python, and all. And next, if you come to admin, there is DS agent configuration, email configuration, custom schedule runs, and custom calendars. You know what the admin do with the cloud tenant and all. There are the same functions performed by admin here also. And also monitoring production status, log files, task failure analysis, troubleshooting. This is monitoring of the work by solution architects and super admins and all. This is what they do with the access of CPI. And next, if you come to security, it plays a key role in security as user roles, and it is W enable, SAP access, security log, and IDP transfer. Generally, all SAP cloud tenants are very, SAP is just it's a top company, top cloud tenants. It creates the products, it's all top in security levels, because no one can just interfere in SAP cloud tenants easily, because they are very highly secured. And if you see data flows, data flow design, data flow management, data flow editor, and data flow debug. These are some data flows. And again we have map columns, join tables, filter data, sort data, group results by specified columns. These are all data flows you just perform according to the data which you want, or which data you want to get. There will be some flow of getting the data. So this and all, like design, management, editing, this and all are part of data flows. You have different data flows here. And this is about CPI. So just I wanted to make sure that how these frameworks are connected to SAP CPI, because we use all these frameworks and ODATA, REST, SOAP, and HTTP methods in integrating and connecting the CPI, which is a middleware, to S4HANA database and all C4HANA clouds and CPQ cloud. This is what what I want to tell you is, there will be C4HANA cloud tenants and CPQ in between CPI and S4HANA. So when the request is sent from CPQ or C4HANA cloud tenants to CPI, in between these we use these frameworks to request information from CPI. Again CPI by using these frameworks request information from S4HANA database. Same like response also goes through CPI to cloud tenants, to C4HANA cloud tenants or CPQ. Let us take CPQ cloud tenant, S4HANA database. In between we will have CPI, which acts as a middleware. If you are requesting information from CPQ to CPI, we will use SOAP application programming interfaces. requesting information from CPQ to CPI, we use SOAP application programming interfaces, SOAP APIs. And then again from CPI, the information is requested from S4HANA database. There you will use SOAP cloud connectors. If it is on premise, if the cloud tenant is on premise, then you will use cloud connectors from S4HANA. Again, S4HANA sends information from S4HANA sends information to CPI, then CPI sends information to CPQ. When the information comes from S4HANA to CPI, there you will use iDocs, which is called intermediate documents. And again from CPI to CPQ, when the information should go from CPI to CPQ, there you will use REST, representation state transfer. So generally what these frameworks in between CPQ, CPI and S4HANA, in between these cloud tenants, now what all the SOAP APIs, cloud connectors, iDocs and REST architecture, what I told, these are the preferable ones. But you can use OData in any of the instead of any framework here, because it is an option. Like everything, OData is an option, it's not a necessary. Mostly SOAP, REST, like that what I said, CPQ, middleware CPI, S4HANA database. CPQ to CPI, when it is requesting, you will use SOAP APIs. Again, from CPI to S4HANA database, when it is requesting, you will use cloud connectors. And again, when the S4HANA, it is responding, sending information by just grasping the request, from S4HANA to CPI, we will use iDocs, intermediate documents. Again from CPI to CPQ, we will use REST architecture, and you can use OData anywhere as it is an option. Generally we will use OData based on the data we want, like we want the old data or we want some specific data by querying. Based on that we can use anything. Even with completely SOAP architecture, everything is done in between CPQ, CPI and S4HANA. Before using these frameworks in between for requesting information and response is given, you need to integrate all these things. Like you need to integrate C4HANA and CPQ, and CPQ and CPI, C4HANA and CPI, and again CPI and S4HANA. You have to integrate all these to use these frameworks for requesting information and transmitting information. This is what complete architecture of SAP Cloud Tenants in using all OData, REST, SOAP, HTTP methods by considering SAP CPI, Cloud Platform Integration, as a middleware. So the entire process just goes like this. And for these things, the first thing you have to learn is HTTP methods, like get, post, put, all these methods you have to learn. And REST framework you have to learn, all the REST application program interfaces you have to know. And also then after learning these two, OData, you have to learn OData as it is completely runs on REST principles. Then you have to learn SOAP. And if you just get to know and learn all these things, OData, SOAP, REST, HTTP methods, then then the getting information, retrieving information and sorting information, then just simply you are the CPI specialist. This is about CPI. CPI, for data transmissions, if you learn HTTP, OData, SOAP, REST, that's enough. And if you learn CPI, then it's completely everything. Like you are completely one of the top. You will become a very lead consultant wherever you go. And this is what the thing about SAP CPI and all these frameworks or languages we used for just integrations or sending and receiving information. Just for sending and receiving information, all we use these frameworks. And with respect to SAP CPI, and this is the final conclusion. And thank you guys. Thank you for bearing with me.